Hello everyone, welcome to my channel. Today we are going to discuss one of the important topics of the chapter atomic structure, not from one particular class but from respect of class 7, 8, 10 and 11. One of the first topic we discuss in this chapter is cathode ray tube experiment. Atomic structure is a chapter where we are actually dealing with how the atom has been subdivided and how we came across the various subparticles. Right? When we have first studied the chapter in class 6 or 7, we were told that atoms are indivisible, right? By John Dalton's atomic theory, that atoms are indivisible in the beginning of 19th century. But somewhere now we know that atoms are very much divisible, and we are now even dividing the protons, electrons also, right? Whatever, this cathode ray tube experiment was one of those experiments which led to the consequence of atoms indivisibility, right? Because Dalton already told atoms are indivisible minute particles, but this says that it is not the case. So the first thing we are going to read today is cathode ray tube experiment. So what exactly is the cathode ray tube? First we need to know that. If you have ancient television, not ancient I mean the previous generation TV, that bigger box one, we have a very thin one, right? Very thin, but the thick ones, this thick rather, sorry, these thick televisions, they were actually this CRT television, the CRT monitors. Even the previous desktop, that is the computers you use, those were also the CRT computers. That is why the size was more bigger. But now it is no more CRT, it is LED, right? So cathode ray tube is having a widespread application. Previously, as I already told, the televisions, the computers, they were all made up of this CRT. So what exactly is a CRT and how is it useful in our chemistry, that we are going to see. So the cathode ray tube looks like a tube. It's a simple like tube. Don't judge my handwriting and my diagram because they are all marvelous. Anyway, so somewhat this is a cathode ray tube. But if we just use a cathode ray tube, that is this tube, this can be any sort of tube, right? So how does this make sense of only using a tube and confirming that no, there is a electron, there is proton, there is neutron, whatever there is? So how? So we need to put up some conditions. So the conditions that they have put up is, they have installed two, not they, I mean the scientists who have done the experiment, right? Not me. So they have introduced two electrodes on two sides. Two electrodes on two sides. And then since there are two electrodes, then there must be a connection between the electrodes. You all have done hydrolysis of water. I mean electrolysis of water, not hydrolysis, that's a wrong term. Electrolysis of water you have done. So in that case also you have used, if you have done it at home, then you have used two pencils like this, right? And then you have connected a wire, then you have put it in a beaker or somewhere, wherever you are doing, right? Then you can see bubbling here. Obviously you cannot use only water, you have to use salt water, right? Only you can do that. So this you have done at home. So whenever you are using two electrodes, you don't just put it around, it will make no sense. So you have to connect the two electrodes. So you are connecting the two electrodes by using some wire. So let us assume that there is a wire which is connecting both of the electrodes, right? Now if they are connected by some wire, then we will apply some electricity also. Rather we will apply some voltage, right? We will apply some voltage. So here there is some voltage, right? Or rather this is a wrong term, this is actually voltmeter. So better is if we apply a battery. So we are applying some voltage, but this cannot be supplied directly by a battery because the voltage is very high. We are coming back to that a little bit afterwards. So this is basically the cathode ray tube's first part. Clear? So we have used two electrodes. Now what are electrodes? Electrodes are certain substances which are capable of conducting electricity. Clear? For now this much will work, but if you are in class 10, then you have already read the definition of electrodes in chapter electrolysis. For others, this is the definition of electrode for now. So electrodes are basically the substances which are capable of conducting electricity in this case. In case of electrolysis, it is something different. Clear? More or less same, but it is a little bit different over there. Anyway, so that's fine. So this is the electrode which is going to be present here. Usually metal electrodes, right? Okay. Next, we have a pipe out here. We have a pipe out here. This pipe is called vacuum pump. What is it called? It is called vacuum pump. So vacuum pump is very, you know what is vacuum? When there is no air present is vacuum, and vacuum pump is very important in this case because when we are performing the CRT experiment, we cannot perform that at normal pressure. What is the normal pressure? Atmosphere. 1 atmosphere is the normal pressure. We cannot do this experiment at normal pressure, that is at 1 atm pressure. So we need to do this experiment at a very low pressure. Clear? We will not perform the experiment in normal circumstance. That has to be noted. That is why we need a vacuum pump, so that we can put out most of the air. Right? We can create a vacuum like situation, but not vacuum, because on vacuum also this will not work. We have excavated everything out of the cathode ray tube, then there is no sense of doing the work. Clear? Why? That I will discuss why it is so. So these are the vacuum pump. Clear? And these are electrodes. I am only highlighting one electrode so that you don't get confused later on. This is electrode. Clear? Electrode, that one is also electrode, right? Now we, depending on which type of experiment you are doing, because cathode ray tube experiment was performed twice, you remember, it was performed twice. One was for electrons, another was for protons. Rather, one was for cathode ray, one was for anode ray, right? Two rays, cathode ray and anode ray. So for cathode ray also we perform CRT experiment, for anode ray also we perform the CRT experiment. So this same experiment has been performed twice, right? And both the cases you will just find is the alteration of these position of the electrodes or position of the marker, either of that is altered, just that's the case. So what I am discussing right now is a general cathode ray tube. I am not specifying whether I am discussing cathode ray or anode ray, because what would the case, there will be a little bit difference in the cathode ray tube arrangement, but nothing as such difference. Clear? Okay. Now this is the basic setup which is done, but the main setup is not done yet, because the main thing that we need is not present. That I will come a little bit later on. Okay. So to perform this experiment, the voltage that we need to apply is almost voltage. I hope you all know what is voltage. See, I don't know physics much, so I don't know what's voltage. I just know the term, forgot the definition. This is around 10,000 volt. So if you understand, the voltage that is coming to your house is how much? Somewhere 220 volt, as far as I remember. 220 only. And this voltage is almost how much times? Calculate, 10,000 volt, which is very high voltage. Clear? So if you think that you can do it by your body voltage, you cannot do it, because your body gets only 220 volt. Rails, that is a rail line, there is a trains, they get how much? They get 11 kilovolt, 11 kV. Right? And metro, third rail of metro, they get around 750 somewhat, 750 direct current, 750 volt direct current. Now I think it has been upgraded, I don't remember. So that's the point. So this is very high voltage, and the pressure conditions in this cathode ray tube experiment is somewhere around 0.001 mm Hg pressure, which is also a pretty low pressure. 0.001 mm Hg pressure means the pressure conditions under which this experiment is performed is also very low. So to get this pressure, you can understand, to get this pressure, how much vacuum like situation we have to create, because in general case it is 1 atm or it is 760 mmHg, which is equal to 1 mm, sorry, 1 atm, so 760, and it is 0.001. So I hope that you can understand that how much gas has to be evacuated. Clear? I will come back to this point later on. After concluding this, I'll ask some questions. There I will come back to this, that why we are dealing in this case. Why is vacuum tube important? We'll come back to that later. But for now, you can understand that the pressure condition is low. In this case, it is around this range, 0.001, or even more lesser also it can be, 0.0001 also it can be. In some cases, it is always 0.001 also is possible. In some cases, it is 0.01 is also possible. Around that range of pressure. Understood? It may be in some books it is given as 0.01 also it is given, in some book it is 0.01, maybe. Depending on book it is changed. Or somewhere you will get this value also. Somewhere you will get this value. Somewhere you might get 0.001 value. That's not the point. Just understand that the pressure is very low. It is usually in the range of 10 to the power minus 2 to the power minus 4. Here I have written minus 3, the average of both. Okay. Anyway, so if the question is coming in your exam, what are the conditions for cathode ray tube experiment? Then your conditions will be these two conditions. Clear? Conditions. Now, major confusion is when, this is actually not a very confusing part, but still, conditions, because I have seen this, that is I am telling. What question is, what are the conditions of CRT experiment or cathode ray tube experiment? Clear? Answer: electrodes. Electrodes. Then another thing is there which I have not told yet. That one. Vacuum pump. Are these the condition of cathode ray tube experiment? Are these your conditions? This is not your condition. If I ask you what is the condition of your home, and you say that I am poor, then that is your condition of the home. But if you say that I have only one mobile, I have one AC, that is not your condition. That is what you are having. That is not a condition. That is something you are boasting of, maybe, but that is not your condition. Condition means the state. You are not telling me about your state. You are telling that I have this, I have that. No, these things are a part of the setup. It is having that. Why are you telling me that is not a condition? Understood? Condition and apparatus is different. Condition and apparatus is different. This is the apparatus. If you don't get the apparatus, you don't do the experiment. Without this apparatus, you cannot perform the experiment. So question is asking condition. You are not supposed to write the apparatus. That is not the question is demanding. Okay, don't cry. It's not something to cry upon. Right? Because I know many people don't like only the subject, thinking that something you have to just study randomly. We don't know what is happening somewhere or the other. If you try to think it, then only something will happen. If you don't try to think on it, nothing will happen. No one can make it happen. That's the point. So, if the question is what are the conditions of the cathode ray tube experiment, then your answer will be voltage and the pressure, a given value based on whatever is given in your book. Okay. You are not supposed to write the setup or the apparatus, whatever, the same thing. You are not supposed to write vacuum pump. You are not supposed to write electrode. You are not supposed to write phosphorescent material. No, that is not asked in the question. Clear? Even if you write, you will get a big zero. No chance of getting marks. Clear? Until you get some grace. So you have to understand that which question demands which particular answer. You are not supposed to beat around the bush in the question paper, right? Sorry, in the answer paper, I mean. You are not supposed to beat around the bush. You have to write your answer. Clear? Okay. So these are the conditions of the cathode ray tube experiment. Alright. Now I have not come to the major point of this experiment. That is, the material is missing. Material is missing. I am coming to the material now. So is the basic general thing clear? Now I am moving on to the cathode ray experiment. Cathode ray experiment. Clear? Till now I have just discussed about the cathode ray tube experiment in general. Now we are moving on to the cathode ray experiment. Okay, or discovery of cathode ray. So the condition I am just removing it because it remains the same. You already know it. It will remain the same. We are moving on to the cathode ray tube experiment, or particularly now cathode ray experiment. This is cathode ray experiment. That means discovery of cathode ray. So tell me, who discovered cathode ray? You already have read in your book. It is William Crookes, right? It is William Crookes. So William Crookes first worked it out and he discovered the cathode ray. Remember, he did not discover electrons. He discovered cathode ray, but not electrons. Clear? So who discovered electrons? Electrons were discovered by J.J. Thomson. Electrons were discovered by J.J. Thomson, who came later on, a little bit afterwards, William Crookes. So first William Crookes discovered the cathode ray. Later on, J.J. Thomson came and he discovered the electrons, right? That means the composing particle of the cathode ray where electrons were proved by J.J. Thomson. We will come to that later on. So what did he do now? Now you tell me that after whatever we have discussed till now, the thing is we have not spoken about the electrons, have we? We have not spoken about the ray. We have spoken about the setup. We have spoken about the conditions, but we have not discussed about the rays. Or how will we see what is happening inside? We have not discussed. We have just started the thing, but we have not discussed that what is your observation, what is happening, what will happen. We have not discussed. So now let us see that what will happen in there. So the experiment is started upon application of this 10,000 volt. Unless I am switching on this 10,000 volt, nothing is going to happen. So let us suppose we are switching on the 10,000 volt source, whatever is the power source. Upon this turning on, what will happen? Current will start flowing from here, then something will happen. But what will I see? Or what did William Crookes see? From this, if we assume that this is going to be my cathode ray tube, then what will William Crookes see? Nothing. William Crookes will see nothing. Why will he see anything? You think. You have to think. You are sitting behind the camera. You are seeing this. You have to think. Because I feel that unless and until you think something, we can't proceed with anything. Okay. So please think. Give it a thought. Pause the video. Think. And then come back. I am explaining anyway. What am I saying is, suppose this is the setup. Okay. The same pressure 0.001 pressure, 10,000 volt, everything is there. Fine. This is the condition. So if this is the setup, under the appropriate condition, what will be William Crookes' observation upon turning on the power source? Will he be able to see the cathode ray? No. Answer is no. Why? Cathode ray is not light. Is it a light? Is it light? Is cathode ray light? No. Cathode ray is not a light. We cannot see electrons. How can we see electrons? They are not colored. Electrons are not colored. Are electrons colored? That we will see, suppose a white light, not a white light, sorry, suppose a yellow light is going. It is not like that a colored light is passing by and I can see. No. Electrons are not visible to us. So we cannot see anything happening. Nor can William Crookes see. Then if something is not happening over here, then how can a scientist understand that if there is any divisibility of atom or not? Because for till then Dalton's theory was very much correct. Now they are working on to prove him wrong, sorry. But if there is nothing to understand that something is coming from here to here or here to there, then there is no way of doing any work. Am I right? There is no way of doing any work. So even I will see whatever you are seeing. Nothing is going to happen. Nothing is going to change because I cannot see the electrons. They are not going to be visible to my eyes, right? So what exactly will William Crookes now do? Now coming to the most important point, that is how to detect the presence of this rays. Because until and unless we understand the presence of this ray, we cannot proceed with anything else. So to determine the presence of this ray or absence of the ray, we are using a biomarker. Correct? But it's not a biomarker. I just joked about it. It's not a biomarker because biomarker is in our body. I just told that so that I could relate with something else. Biomarkers. So what are biomarkers? Biomarkers are something that we use in our body to detect. Biomarker. They are usually chemical compounds again inside our body which is not harmful to our body but which can sometimes glow, that is emit some light so that we can detect that where it is under UV light. Under normal conditions will not happen. So that are some points, right? And if you are in class 11 or 12, then you must have read about this more in details. Biomarker. Even markers are present. If you are reading biotech in class 12, then also you will know that markers are present on vectors also. They also have markers. So marker it is to be there. It is a good characteristic of a vector to be a marker. Anyway, I don't want to break your head out here teaching biology. Okay, so what I was telling is I have to have a marker. I have to have a marker so that I can understand that where, from where, to where, or even if there is a ray or not. So to detect the presence of ray, we will use some compound. What is the compound? First, coming to the compound, we will use a phosphorescent substance. What substance? Phosphorescent substance. So what is a phosphorescent substance? Phosphorescent substance means it is a substance which, I am not writing in full sentence, which glows when high energy particles strike on it. Understood? When high energy particles strike on that particular substance, which is a phosphorescent substance, then it will briefly glow. Now you see, if I am installing a barrier, that is this barrier, phosphorescent material, then what will happen? If something strikes on that, then this should glow, this particular thing will glow, then I can understand that yes, something has struck on that. And that something is which is not visible to us, but the glow will prove that yes, it is there. Understood? So to understand if something has struck the substance, we will use this guy. Understood? Now where to use the guy? Right? We have this phosphorescent substance, we can use here, we can use here, here, or here. We have many space. Here also we can use. So we have many space to use, but where we will use? Again, sensible option you have to choose. If you suppose you are installing over here, why you are installing there? Why it will go there randomly? It will not go. No need to. You can install. It will be your loss. See, it will go in from this direction to this direction because current is not flowing in this way. Na? Current is not flowing from that way. Current will not flow from here. Na? Current is not going in this direction. Then why will it install here? Not needed. So save your time. So you are not needed to install over here. So we are not going to install on the sides. Not needed. Either you will install here or here or here or here. Anywhere you can install. Clear? Understood? Okay. Now, if you here install here and here, then it will obstruct the flow of current because they are not conductors of electricity usually. So if you install over here, then it will usually cause obstruction in the flow of current. So we will avoid obstructing the flow of current. So what we will do mostly is we will place it behind the two electrodes, not the two electrodes. I'm coming to which one. We will place it behind the electrode so that our work becomes easier because we are not going to obstruct the flow of current. So let us place it behind. পিছনে রাখি সুবিধা হবে. No need to block the current flow. Now, where? Which electrode? Because I have two electrodes. I am having two electrodes. So behind which electrode am I going to place? I am going to place it behind which electrode? My question. Behind which electrode? So for that I need to know both the electrodes. Right or wrong? I need to know both the electrodes. So now I am again coming back to something different. Suppose in physics you have already learned that suppose this is a battery. So this battery has two terminals. If you even see your battery of anything, then you will find the battery has two terminals. One is a positive terminal and second is a negative terminal. As far as I remember, this will be positive, this will be negative. Might be the ulta also. I don't remember exactly. But I think this one. Bigger one is positive, smaller one is negative. Might be the opposite also. But whatever I am trying to explain is not exactly physics, something else. So whatever. So one is positive plate, another one is negative plate. Even in the battery, we find one side is positive side, another side is negative side. It is mentioned there, plus minus, right? So plus and minus is mentioned over there, right? So here also, this battery will also have a plus minus. Cell if I use, then plus minus. So one end will be connected to the positive plate. Here also, if you see that this end is connected to the positive plate, this one, and this end is connected to the negative plate, this one, right? So two electrodes are not behaving in the same manner because one is connected to the positive plate, sorry, and another one is connected to the negative plate. Negative plate is electron rich, positive plate is electron deficient, right? So it will pull up the electrons toward itself, negative charge will throw the electrons, whatever, that is again physics. So positive plate has one electrode connected to itself, negative plate has one electrode connected to itself. So both the electrodes are definitely not the same electrodes. Now is the thing that you have to remember. The electrode connected to the positive plate. I am not talking about physics, I am talking about chemistry. The electrode connected to the positive plate is called anode. Okay. So this one will be the anode and this is negative will be the cathode. So the electrode connected to the positive plate is always called anode because we will deal it several times after this. In class 9, 10, 11, 12 everywhere you will find this thing, and if you make up a mess of it then চিরকালই mess থেকে যাবে. It will never go because this thing everyone means 90% or 85% will make a mistake. Positive plate will go to cathode, negative plate will go to anode. এই ভুলটা হবেই. Why? If you understand it, why there will be the mistake? Positive plate is connected to the electrode, then it is called anode. Negative plate connected to the electrode is called cathode. মাথায় ঢুকিয়ে নেওয়া যত ভালো তত তাড়াতাড়ি করতে হবে সেটা. বুঝতে পেরেছো? যত দেরি করে হবে পরে ক্লাস ঢুকিয়ে মাথায়, ও আর মাথায় ঢুকবে না. সো যত তাড়াতাড়ি মাথায় ঢোকাবে তত এটা মনে থাকবে, তাহলেই মাথা থেকে বেরিয়ে যাবে, তারপর গন্ডগোল করবে. Point is the electrode connected to the positive plate is called what? Anode. Negative plate এর সাথে connected electrode is called cathode. Now how to remember? See, positive is anode, right, and negative is cathode. Now there is a very interesting thing to remember this. How? See, anode A আছে, cathode C আছে. Anode A আছে, cathode C আছে. Anode as A, cathode as C. Now you know two different types of ions. Do you know that? Cations and anions. Two types of ions, cations and anions. Cation has C, so C will always go to C. C will always go to C. And anion has A, so this will always go to. Clear? Cation will always go towards cation, anion will always go towards anode. Okay, cation will go towards cathode, anion will go towards anode. This will be needed later on also. Don't think that I am speaking nonsense out here. This will be needed later on, so better to remember. So this is the way how can you remember. So you see, if cations are positive charge, that much you all know, cations are positive charge, anions are negative charge. So if cations are going towards cathode, then positive will definitely not go towards positive. Basic physics. Only the opposite charges will attract. Same charges will not attract. I am not talking about the society right now. Whatever. So positive charge will always be attracted by the negative charge. Negative charge will be attracted by positive charge. So if cations are the positive charge, then they will definitely go to cathode, means cathode is negative. So cathode is negative. So that is the way you remember. I am just giving you the way you remember. Now you have to remember whichever way you want to remember. If you have some other way to remember, remember that also, not a big problem. We want correct answers, not nonsense answers. Clear? Okay. So we have two types. One is anode, one is cathode. Now quickly tell me which one is the anode over here and which one is the cathode over here. Pause the video. Try to answer on your own. Then see the answer. Okay. So which one is the anode over here? This one, right? And which one is the cathode over here? This one, right? Now, since we are performing the cathode ray tube experiment, we will place the phosphorescent substance behind the anode. So we will place it over here. Clear? So this is what? This is nothing but the phosphorescence. Okay, we have not explained what is phosphorescent substance. Example দেওয়া হয়নি. So what is the example? Best example you will find is zinc sulfide screen. Other than that also you will find this caustic soda. Na, caustic soda na. Not caustic soda, sorry. Soda lime glass. Caustic soda is something different. Soda lime glass. These two are usually the phosphorescent material. Usually for this experiment we use the soda lime glass only. But zinc sulfide screen also can be used. So it is a little bit costly. Nothing else. So phosphorescent materials we have in stock too. If it is asked what is, because questions are asked what is phosphorescent material, give one example, then we will look in your answer for the keyword high energy particles strike on it, then it glows. Okay, so you, if you write anything that it glows, only glows, it does not work, because only so anything can glow on its own. There are many other materials also that can glow on its own, but that does not mean that it is phosphorescent. Phosphorescent means that when high energy particles will strike on it, then it will glow, not general. My AC remote also will glow if I turn off the light, then also it will start glowing. Does it is phosphorescent material? No. When high energy particle will strike, then only it will glow. Then it is a phosphorescent material. Otherwise, it is a fluorescent material simply, not a big deal. Okay. So you have to first read. If you read, then you can understand it very easily. Okay. So we have understood that we have to install a phosphorescent substance behind the anode. Why anode? Because direction will be from cathode to anode. A little bit background study of this is required. Right? Cathode to anode is the direction of the electrons. Electrons of cathode ray. So we will place it behind the anode so that we can understand that it is coming from this direction to that direction. Okay, now you will ask me that why did or how did William Crookes know that we have to place it behind the anode? That question I cannot answer. For that you have to go and ask William Crookes. Right? So you have to ask that to William Crookes, that why did he place? Maybe it is just a coincidence. He just placed it and it happened. That might be the only answer for now, because I don't know why he placed it there. Maybe he had just coincidentally placed it there. Okay, whatever. So we are placing the phosphorescent material behind the anode so that the cathode ray which is traveling from cathode to anode can strike the zinc sulfide screen. Now you think, to strike the zinc sulfide screen, what has to be done? Before that, let us just quickly write the point that I am going with ZNS. You will find in your book it is given with soda lime. Both will be working. Okay. So ZNS screen placed okay So ZNS screen has been placed behind the anode. Now it has been placed behind the anode, but that's not the only point I'm dealing with. Why? Because it is placed behind the anode, but if the anode is in front, just now I was talking that if the zinc sulfide was here, then what would have done? It would have obstructed the flow of current. If the zinc sulfide is behind the anode, then the anode will obstruct this electrons. Now electrons are coming from this direction in this way, right? Electrons are coming in this way. So if the electron is present in their way, then this will not allow it to pass there. Obviously the electrode is not this much only, it is entirely covering, so it will not allow this rays to hit only here. Then again the same case will happen, that I will not be able to see whatever I want to see. No observation. Understanding what am I saying? Suppose in this dying Gorom summer, 45 degrees somewhere in Rajasthan's Bikaner, somewhere in Rajasthan's Bikaner only I heard. Anyway, somewhere in Rajasthan, 45 degree, 45.3 degree. So there what will the people do? They will install, even we are also installing, that we call in Bangla called jala, right? Not that jala, it is a different jala, the matir jala, right? We all use it at homes. Middle class family, they will definitely use it. What happens in a jala? A jala is also like a big ghoti type of thing, right? It is like a big ghoti type of thing. Somewhere, not exactly like this. It is a little bit thicker like this. My diagram is very fabulous, so don't comment on that. So somewhere like this, a bigger one. So if we, let us pour full water like this and let it rest for some time, then what happens? When you drink water from inside, it gets thanda. Why? We are not placing this in a fridge, right? Do we? No. We don't place this in a fridge because it's too big for a fridge. So how it is getting? Why? Because here there are minute holes everywhere. Everywhere in this jala, there are minute holes through which continuous evaporation of water is happening. And evaporation only makes it cool. You already know evaporation makes it cool. So due to continuous evaporation of water, this is getting cool. So if we are using a jala with no such holes, then ever will the water get cool? No, instead water will get more warm. Means whatever is a normal condition. So if there is no such holes, then water can never get garam because there is no hole. So no hole, no garam. So what is the condition of being garam? The condition of being garam is that these holes need to be closed. But moment I will keep these holes intact, then continuous evaporation will happen and nothing garam will happen. It will get thanda. Now come to here. If this substance has to glow, then something has to strike on that substance, and to strike on that substance I need to remove this barrier. Now if you think that I will just simply remove the anode and throw it from the setup, then that is not going to work, because that will disturb the apparatus only. So throwing away the anode is not an option for me. Then what is the option? Option is this. Not jala. I cannot place a jala over there. No. What is my option is, I can install the holes here also. Why not? I will make it perforated. That is called a perforated anode. Very important point of cathode ray tube experiment is perforated anode. These are all questions that are asked in the examinations. So I am just telling you all the points. Listen and watch properly, then your chapter will be ready here itself. Okay, so perforated anode is present. Clear? Why perforated? I just now explained. I will not explain anymore because it will take more time. So we will perforate the anode so that the electrons, the electrode, the cathode ray, they can easily pass through the anode and ultimately strike that zinc sulfide screen so that it will glow. Clear? So this is the entire thing about cathode ray tube experiment for detection of cathode ray. So William Crookes has performed this entire set of thing to detect the presence of cathode ray. Sorry. So after he found that there is a glow, so he told that yes, something has passed, and since he saw that the direction of the cathode ray is from the cathode to the anode, therefore it is called cathode ray. Okay, so obviously you need to know the direction. I hope the direction you all know. So what is the direction of the ray? Cathode to anode, because cathode is negative to positive. Negative to positive only it will go, because it's negatively charged ray. It will go towards the positive plate. So negative to positive, or the cathode to anode is the direction of the cathode ray. And this is the cathode ray tube experiment which is performed by William Crookes for detection of cathode ray, not for the detection of electrons. Clear or not clear? Clear? Till this much. Is it clear? Think and tell me, because now we are going to move on to the next thing, that is J.J. Thomson's electron discovery. Tell me, clear? That we have understood William Crookes' experiment, we are going to now understand J.J. Thomson's experiment about proving they are electrons. William Crookes already told us that yes, they are composed of negatively charged particles, which is cathode ray, right? But what are those particles that we don't know? Clear? That particles, what are they? We don't know. So for detection of that particles, J.J. Thomson has arrived, and he performed not the cathode ray tube experiment but the modified experiment on cathode ray tube. What he did was simply, is very simple thing, generally not asked in the exam, but just to know, he placed a electric field around the cathode ray tube. He gave electric field. Clear? So if you have read physics from class 12 or class 10, then electric field, magnetic field, they have two poles, not pole, south pole, positive pole, negative pole. So if you are applying electric field, or a magnetic field also can be applied, no point in that. Magnetic field also or electric field, both have positive and negative plate. Clear? So if this is a negative and this is a positive plate, then upon application of the electric field, what will happen? The cathode ray which was going towards this from this side is a straight path. Now whether it is a straight path or not, that we will come. We can conclude it is straight path. But for now you just accept the fact that it is straight path. I will prove it that it is straight path after some time. So this is going to be coming in straight path. So if it is coming in a straight path, it is seen that they get deviated like this. That means they no longer strike over here. Instead, the rays get deviated. It is seen, because might be he has placed zinc sulfide skin over there also. That further details is not mentioned anywhere. But that rays will get deviated. That is why your sense also you can understand that it is deviated. So this proves that they are the negatively charged particle, and J.J. Thomson named these particles as electrons. Clear? So it was named that negatively charged particles called electrons. Negatively charged clear negatively charged particles called electrons, which was proven by J.J. Thomson. Clear? This is all about the cathode ray tube experiment which we have discussed in this video. Clear? I think the video has already exceeded more or less 30 minutes, more than 30 minutes, probably clocking 1 hour. So let it be up to this only in this video. We have explained it in much details. In the part 2 of the video, we will discuss the property of the cathode ray tube experiment. That is, sorry, the property of the cathode rays and electrons, and then we will move on to the anode ray experiment, because I don't think we can continue in this video because it is a very long video. Then I don't want to burden with a very long video, so let it be up to this. In the next lecture, part 2 of this lecture, we will discuss the properties and the anode ray experiment. Okay, so I hope that you have understood the cathode ray experiment, and I hope that you will never forget it and try to take it very simple. If you take chemistry as very complicated subject, then it will remain complicated forever. If you take it as a very easy subject, not very easy, take it as an easy subject, understandable subject, then you can understand it and you can do very good in that subject. Same applies for physics also, any subject. If you try to understand the subject, it is okay. If you don't try, never okay. Okay. Thank you for watching the video. Let us meet in the part 2 of the video.